wave properties. The attributes that waves have that help us to calculate what they are and how they operate.
Miss Sarah?
Yes?
So I forgot to email you, but I was kind of confused on this part. Like, put them in, I was like, what? But like, I forgot to email you, so if we do it today, then I'll just write them down instead of cutting them out.
Yeah, that's fine. Okay, now, this one's a bit awkward. Do not start cutting it out yet. I'm actually going to show you what this looks like, because this one's a bit strange. The bottom 3 boxes are actual flip-flaps. You're not supposed to cut.
I already cut it out.
Okay, did you cut it out properly?
I cut it out properly.
Great. If you cut it out properly, then we're good. If you cut it out improperly, I don't have a solution for you. Usually I
didn't cut it out at all, so.
I cut it out correctly.
I didn't cut it out at all, so I'm good.
Yeah. So this is actually
Miss Sarah, what is this?
It's wave properties, Oak.
Yeah, what is this paper called?
Miss
Wave
Sarah,
properties.
I already did this last week. I did it wrong. I glued it wrong then, apparently. Shoot.
That's okay. Because if you cut it out or glued it wrong, you actually will have room towards the bottom of your page. So instead of writing it out under the flip-flaps, you can just write it below. That's no big deal.
Okay. Thank you.
So do you only glue the top half part?
Yeah, so this wave diagram, that's the part that we're going to glue down. So we're going to carefully look for that line through the paper and then use our box cross method to make sure that the top part, our diagram, is glued down securely. And then we're going to affix it to page 21, wave properties. And it should fit perfect side by side.
But you must do a YouTube tag. I'm gonna go to a different room and try to find this.
Where do we put the bottom ones, like these ones?
So those little ones,
You cut them out.
Those little ones you can cut out because we're gonna glue them here into these boxes. I'm just gonna write it down because like I know my handwriting is small enough and neat enough to fit in the boxes. So if you would prefer to do that, you can. I just included those cut out because I know not everybody likes their handwriting or has neat enough handwriting or small enough handwriting to fit there.
Hey, Miss Sarah.
Yeah.
Can I turn mine sideways?
Yeah. Yes, you can. Getting a million emails.
Mr. I have a question.
I have an answer.
So, does everybody in this meeting have you on their screen?
I hope so.
No, people like everyone that talks like they'll transfer to the main screen.
Yeah.
So what you can do, is you can click the button that says Gallery View, and you can pin the video, my video.
Hey, Julian.
You can pin that so that it is just me.
If there's on my tablet, I can just like swipe through.
Yeah.
And like it shows like everybody. Or if I go like to the main screen, it's just you and me. But I
well, and
rather
on the-
see everybody else too.
On the different devices, it's different. Like how it presents itself is different.
Yeah.
But for sure, if you go to the gallery view
Yeah.
and then pin the video and then go back to speaker view, I think it stays as this video. At least that's what Kylie was saying. So
Yeah, because I like from the last couple of days I've had at least you on there.
yeah.
So.
Okay.
That's good.
So we're gonna start with these 3 basic terms. Now there's actually 5 wave properties. We're just gonna start with these 3 because these 3 are the easiest to see. Wavelength. In science, we don't name things very complicated. This is the length of a wave. Okay? Specifically speaking, okay, it's a wave cycle. So let me zoom in here and then refocus the camera a little bit. Okay? So this is the length of one wave cycle.
I have that exact same sentence.
Perfect. One wave cycle looks like that in a transverse wave. Okay? So it's the crest to crest. Or it could be trough to trough. The point is that you're starting in one place and stopping in another. Welcome, Cordelia. We are just starting with wavelength. We only just started. So make sure you have your science notebook. Go ahead and get this cut out. And we started with the wavelength flip-flap. And then what we're actually going to do, everybody, is we're going to zoom up. We're going to look at our diagram. Figure out which one of those 3 do you think to yourself now, which one is going to be that wavelength? Which one's kind of going from crest to crest? Or is starting in the same place and ending in the same place?
Wait, Miss Sarah, what was the question?
So what we're going to do is you have those 3 blanks in the diagram. We're going to think to ourselves, which one of these 3 is the wavelength? Okay. I think we all got this written down. So now we're going to look. These are our 3 options here. Okay, let's call this one. We got A, B, C. Which one is representing that one wave cycle? Which one is representing a wavelength? A, B, or C? Type it in the chat. Which one you think it is?
That's fantastic.
Wait, what was the question?
We're looking at our diagram.
this.
We're looking at
Yes.
A, we're looking at B, we're looking at C, and now we're typing in the chat which one we think,
When did that start, you guys? 2
think
days?
is wavelength.
1 week.
No, semi-on. It is.
All right, I'm glad to see that nobody is saying A. Oh, Clayton, do you have a question? What's up, Clayton?
Never mind, I was...
Okay, never mind. All right, I'm glad to see nobody's really saying A. This is not going to be that wavelength. We're starting here and stopping here. That's not one wave cycle. A popular answer that I'm seeing is this C, that actually spans from here all the way down here to this 1 second marker. And that's an excellent guess, but it is incorrect. Remember, we are looking to start in one place and stop in another. So if we look here at B, we are starting here, We're going up one full thing, down one full thing, and ending right there. Okay? So this is that wavelength. If you're thinking about the picture that I drew, where I said, well, it's from crest to crest. Let me find a Sharpie here. Or marker. Marker will work. That crest to crest. Okay? So here's the crest. I'm going down, all the way down, back up to the top of the crest. See how I've covered a full wavelength? Crest to crest. I could do the same thing if I went from trough to trough. I can start with this half, come up, go down, and then end right there. So it's one full wave cycle. It includes one complete crest and one complete trough. Boom. Is that making sense? Seeing general head nods. Okay.
Yeah, that makes sense, kind of.
Okay. All right. So then let's come down. Let's talk about amplitude. Amplitude. Okay. Amplitude is the distance covered between the crest of a wave and the rest position. So you need to know what the rest position is, or that equilibrium. Okay? It is defined as the height of a wave. We can also say that it's the maximum or max displacement from the equilibrium. Equilibrium.
Hey, Mrs. Derek,
Yep, Casey.
if my thing looks like I'm looking away, I actually put an HDMI in my laptop into the TV, so I'm actually watching the TV, okay?
Hey, it's fine.
Mr.
Yes?
So is this pretty much the same thing as what you have? Is the height of a wave?
Yes, height of a wave.
Okay, because I can't really see, because like pretty much kind of everybody's kind of blurry in a way.
Okay.
But yeah, because I just wanted to make sure.
Yep. So if we're looking at a transverse wave, the height of the wave, that is the amplitude. So this one's going to be really easy. If you go up and look at your diagram, which one of those, A or C, is representing amplitude? Type it in the chat. Yes, it is A. A, looking up here, this is that amplitude. Okay, that's that maximum displacement. This big thick line down here in the middle, this is our rest position, which means this right here is going to be our amplitude, here or here, that maximum displacement. Now, frequency, yesterday, when we were talking about yesterday and Monday, when we were talking about waves having a constant speed, the frequency is the measurement of a wave's speed. So just like in a car, how you have miles per hour, you have a length per a time frame. Frequency is wavelengths per second. Emily, yes, I will show wavelength at the end of class to answer your question on whether or not I can show that wavelength again.
Mr.
Yes?
So what I have down for frequency is the number of times a wave cycles in 1 second.
Yes. So, when we look at that frequency definition, just like we were talking about speed, okay, this is the number of wavelengths per second. So again, we have a transverse wave. We are looking for the number of complete crests and complete troughs. So you have to have one complete crest and one complete trough in a wavelength. So if we're looking at this, I'm actually going to do it in a slightly different color so we can see. And go back to pink. I have one complete crest and one complete trough here. And then I have another complete crest and complete trough here. So that's 1, 2. That's 2 wavelengths per second. Oops. So that C, when we look in on the diagram, let's see, let me zoom out a little bit. Boop. We can see that if this is 0, right there is a 1. That's our 1 second time frame. So how many complete crests and complete troughs are here? What is the frequency of this wave? What do you think the frequency of this wave is?
Two.
It's 2. 2 wavelengths per second. We've got 1 complete crest, 1 complete trough, 1 complete crest, 1 complete trough. 1, 2. Now this one, for learning purposes, is neatly laid out with these boxes here so you can count. There's 1 crest, there's 1 trough, there's 1 crest, there's 1 trough. Not all of your waves are going to be depicted in this manner. So you need to know 1 complete crest and trough for that frequency per second.